Hi everyone, hear me okay? Okay, good. So thanks very much for joining me here for the next hour. I think this is the last session before lunch, right? So I'll try and finish a little bit early so you can get to the front of the queue for lunch. So for those of you who don't know me, my name's Adam. I'm originally from England in the UK. I've lived in Switzerland for the last 25 years. And it's really nice to be back in Porto, because usually when I come to Portugal, I visit the Algarve because my mum has a property there. But there's so many English people there, it's like being in a kind of like a hot England. So it's nice to be back in a part of Portugal which feels like Portugal. So I usually talk about things like architecture and service orientation and service boundaries and microservices. But today I'm going to go down to code and building code, so like the really fun stuff. So if you like computers and writing code, then hopefully this talk is for you. So this is primarily a talk about simplicity. I often describe myself as a software simplifier, because one of the heuristics I've seen throughout my career for evolvable, maintainable, and readable code is the simpler the better. And there's one philosophy in particular which captures that quite well, and it is, if this clicker works, it is this, right? Do one thing and do it well. Has anyone here heard of Unix? All right, pretty much everyone, okay. So Unix, I won't describe what that is, I guess you know more or less what it is. This is an extract from the Unix philosophy, okay? Or in fact, it's kind of like a summarization and a paraphrasing of the Unix philosophy. Do one thing and do it well. Unix was developed in the late 1960s at Bell Labs, and the philosophy was originated by a guy called Ken Thompson, who actually wrote the first version of Unix. And it's actually a lot longer than this. It was first documented by a guy called Doug McIlroy in 1978. It's actually a lot longer than this, but it's often been distilled down to these three things. So write programs that do one thing and do it well, to work together, and to handle text streams, right? Because that is a universal interface. And I'll show you a bit of that in a second. So let's have a look at some Unix commands, okay? Some Unix programs. So I'm going to switch to a terminal, and which you can now see. Okay, is that big enough at the back? More or less, yeah. Okay. So Unix or Unix-like systems, and I'm using Mac OS here, which is a Unix-like system. It's not Unix, but it's designed to be more or less compatible to Unix. So it comes with standard programs like ls. Okay, so ls just reads the contents of a directory and prints it onto the screen. And you have various options, like you can do it in list form, and then you get things like the permissions on the file, who owns it, the size of the file, the date it was modified. You can do other things like, what is it? Okay, A to see hidden files and that kind of thing. Fairly simple command. There's another command called cat, right? And cat is actually for concatenating files. But you can abuse it by concatenating the file with nothing, and then you just get the contents of that file, right? So it's a very useful thing for just looking at the contents of a file. So let's have a look what we've got in our directory again. We've got this. We've got these hi files, hi txt files, which I'll use in a second. So let's have a look at the contents of, let's say, hi1txt. That's what's in that file, and then I can look at the contents of hi2. That's what's in that file. And now I can actually concatenate, right? This is actually what it's designed for. It's designed for concatenating things together. So if I do that, then I get the contents of both files concatenated together, right? Dead simple. Then we've got slightly more, well, there's another command like sort is actually quite useful, right? Sort, very self-explanatory. It just sorts the lines, so I can just pass, say, the contents of one of the files to that, and they're sorted. You can reverse it, I think, with -r. So again, very, very simple. Sed, or the stream editor, is slightly more complex. This is designed to take a stream of text in, edit it, and output another stream of text. Okay, so I can do something like, it takes a regular expression, so I can say substitute hi with hello, for example, and that file. Oops, yes, I'm start the terminator. So that just substitutes hi with hello. Okay, dead simple. Then we've got global regular expression print, or grep as it's more commonly known. And here we can actually pick out specific content from a file. So you get a text input stream in, you pick out specific content and lines, and you output just that content. So I can do something like grep hi from high 1. And that just picks out the lines with high in them, right? And now, this is the really powerful bit, is I can concatenate these things. I can pipe the output of one program to another program. So I can do something like concatenate the two files, as we saw before, and using the pipe symbol, I can say the output of the cat program should be the input to the sort program, okay? And then I get the files concatenated and then sorted, right? And then I can pipe other things together, like I can do the substitution we saw before. So let's substitute hi for hello. Oops, that terminator. And then we can put it through grep, and we can pick out the hello. And that should all work, right? So we get the hellos. But it's not very efficient. It's actually probably better to change the order slightly, because we're sorting the entire contents of high 1 and hand 2, and only then are we filtering it and making it smaller. So it doesn't matter for these small little files, but if you've got millions of lines, you probably want to make it more efficient. So you might concatenate them first, and let's say, then we do the grep, right? So we pull out the lines we want. So we grep for high. So we've immediately got a much smaller set of lines, and then we can do the sed hi for hello, and then we can sort right at the end. And that's all work. So it's just each of these programs does one thing, and it does it well, right? This is a very good demonstration of the Unix philosophy. Where are my slides? Okay, so they've been around for a long time. Okay, so cat, concatenate, has been around from 1971. Sort 1973, sed 1974, grep 1973, right? They've been around for ages, right? Before most of us were born, okay? And why? Because they've never tried to do one more thing, right? They've never been replaced because they do exactly what they're designed to do. Concatenate files, sort text, edit text, and search text efficiently and without any other complexity, right? They do have various options which you can dig into, but the basic canonical usage is very, very simple. And that leads to certain properties which makes these tools enduring. So simplicity, right? For new users and experts alike, they're straightforward to use without having to look up options in syntax. As I said, you can do that, but you don't have to. Compatibility, right? They all adhere to something called POSIX, which basically defines those standard input and output streams, so standard in and standard out, you may have heard. They are ubiquitous, right? So Linux comes with this stuff built in. It's Unix compatible. It's a Unix-like system. Mac OS as well. Windows, your mileage may vary a little bit. I mean, we've got WSL on Windows now, which is basically kind of like gives you Linux and Windows. There's also native ports as well, so you can even do this stuff on Windows, right? If that really is your preferred OS. Efficiency, they're fast, they have a low overhead, they're very efficient for many tasks. Stability, right? They haven't really changed much over the years. I mean, things have been added, but and they're mature. They're kind of done, right? Things have been tweaked and added here and there, but you don't see big bang new releases of like sed and grep coming out these days because they already do what they're designed to do, and they do it in a good way. And they're so simple and effective that their continued relevance in Unix-like OSs is ensured. They adhere to that philosophy. They've been around for 50 years. They're probably going to be around for another 50. Right? That's my prediction. So you might be thinking, well, that's all nice and good, but what does this have to do with tool chains? Well, I'd like to take you on just a little journey through the tool chains that I've used over the years. So back in the 80s, I used one of these, the BBC Micro. This was so anyone who was in the UK in the 80s might have seen this thing. This was a joint project between the UK government and the BBC to put at least one of these in every school in the UK. So I was in quite a small school, so we only had one. And we weren't allowed to load games onto it, right? Because they had a lot of games, but we weren't allowed to load them in. So what I did is I got my programming book, which had game listings in it, and I learnt these things off by heart. And I'd go to this at lunchtime, write a game, and then we'd play a game on it, right? Because that was the only way to do it. And I've actually managed to recreate that. Okay, this was not an easy task because I've forgotten everything by now. But I've got here BBC emulator, right? It's online, and I wrote this game, which I used to be able to write in like a minute, just remembering it, but it took me a lot of time to actually figure this out. Anyone guess what kind of game this is? Racing game? Yes, yeah. I mean, car and that kind of, those kinds of pothole and those kinds of things kind of give it away. And I can get this code, I can paste it into here, which I did earlier. And the tool chain here is very simple, right? You've got basically a list command, which lists your program. Resetting the computer was a key on the keyboard, right? You click break, and you actually reset the computer. But luckily, you could get your old program back by typing old. And then you could list it, and then you could run it, right? So it's very simple. This road gets more and more windy. You get more and more of these red things. I thought that was my game for a second. I've never got up to, I'm always trying to get to 1,000. I haven't done it yet, but that might take a while. So when you crash, okay, game over, press place to stay again. You can escape, you can list it again, and so forth. And that's basically the tool chain, right? It's just list and run is basically the thing. So fast forwarding to 1998. This is where this is one of my early jobs. I had an early job in working in finance. Actually, it was dead boring. It was so dull. But I used Excel quite a lot, and I discovered this. If you can see it up here, this record macro button, right? So I thought, oh, I wonder what that does. So I pressed it, and I did some stuff in the spreadsheet, and then this other window popped up, and I thought, this looks a bit familiar. This looks a bit like what I used to do back on the BBC. So I started playing with it, and I ended up just automating all kinds of stuff. I actually automated my own job, and I automated someone else's job. I didn't tell them for a while. I just kind of pressed the button and sat there for the rest of the day. So that was quite nice. But after a while, I got bored and said, look, I've automated my job. And then I gradually kind of moved into becoming a software developer and building stuff. I moved on to VB, right? So not VB.net. The old VB. Anyone work with this? Oh, good. A few of you. Less and less hands every year, but this was, you could do some pretty good stuff with it. It was a bit clunky and wasn't the best language, but we did a lot of useful stuff with that. Then eventually ended up on VisualStudio.net. It was actually called VisualStudio.net at the beginning, which came into existence in about 2002, and a lot of us are still using today, and I still use that a lot today. I don't know if anyone remembers this. Remember this kind of like right-click deploy thing in Visual Studio? Yeah, yeah. See a few wry smiles. So the idea here was that you could just deploy from your machine, right? You didn't have to set up fancy build servers and all that kind of stuff. You just deploy from your machine, and that's all good. If that machine works, or if that developer who knows how to do that is in that day. But over the years, I learned about things like source control and testing and continuous integration, and the most novel idea of all, for me at the time, teamwork, okay? Because until then, I was kind of working as a kind of lone developer directly for users and just producing magical things for them, and everyone was happy. But when I joined a development team, I realized that doesn't really scale. So I started to learn the value of working together, and one of the steps we took towards that was to introduce a continuous integration system. At the beginning, we used cruisecontrol.net. Okay, it's a very simplistic build server. We had one machine sitting there as the server, which basically pulled all the code. Every time we committed code, it would pull the code off that branch, and it would build it in a repeatable way. So it didn't matter who was in or whose machine was working. So long as that server was working, anyone could build, test, and deploy the code. Later on, we moved on to JetBrains TeamCity, far more fully featured build server system, and that served us very, very well. That's still around today. And then we kind of got a bit more intricate with our builds. It wasn't enough just to build the code. We wanted to test it. We wanted to do various different test suites. I don't know, we might be spinning up containers and doing things and building deployment packages and things. It's a very rich system. You can do a lot with that. But after a while, a problem developed. We started to realize that it wasn't that easy to tell if we were going to break the build before we pushed the code, because there was a lot of stuff happening here which was pretty involved to replicate on our local dev workstations. Has anyone found themselves in this kind of like position before? This guy is saying that the main thing missing is being able to run this stuff locally, and you very often ended up in this fix the build, push it, fix the build, fix the build, fix the build. I see that a few people have been here before, and in your commit history you just see these fix the build, because you just don't know if you're going to fix the build until you actually push it onto the build server, and then it's either red or green, right? And then you get your feedback. And as this guy's saying here, this can be a 20-minute feedback loop, while you get your coffee, or it could be even 2 hours if you've got a massive code base with lots of tests. It's not a very efficient way to work. So I'm going to introduce another Unix program here called make, right? And this first appeared on the scene about 1976, so relatively new kid on the block, right? But make is the same. It's followed the same kind of story. Like there have been iterations and additions, but it's largely stable. It's kind of like a done thing. So I should be able to show you make. Let's switch to Visual Studio Code. Okay, and make still works, right? So a Unix-like system still ships with make, right? So on Mac OS, this is a very simple make file. So what we're doing here is we're saying we're defining like a build step in this build script, and we're defining a test step here. And the test depends on build. Okay, so we need to build first, and then we can test. And I know you can just write .NET test, right, and it will do it. But this is a very, very simple example, okay? But it's sometimes nice to do those things in 2 separate steps so you can see exactly which part was the failure, right? So I often like to just split them up for that as a very first step in that way. And we're saying no build when we run .NET test because it doesn't seem to be working. Because we've obviously built it in the previous step, right? And then the default goal is test. So if we don't specify which step to run, it will just run the test step. And I do that simply by running make. Okay, and then we get our .NET build working. That's a lot slower than I expected. And then we get our .NET test working, and it's worked, okay? And the libraries and the tests themselves are just very, very simple. They're not really doing much at all. So that's all fine, and this is actually, so where we've got our .NET test command, that is basically just shell script, right? So bash or whatever you're using. You can write any script you like within one of these tests, and you can get really complex. Like if you know the shell really well, you can write really complex stuff in these build steps, right? But this is just a very simple example to illustrate it. And that's all fine, but what if you don't know shell that well, right? So there was a guy called Jim Weyer who invented a thing called rake, and this is basically Ruby make, okay? So it's make, but you can write Ruby instead of writing a shell script. And this was great for Ruby developers because they knew Ruby, right? So they could write nice, complex stuff in here, the stuff that they needed in Ruby, in the same language they're using to develop their app. So the syntax is fairly similar. We have a build task, and here we're using this lovely sh command, right, from Ruby. And we're running a .NET build, and here we're saying the test task depends on build, exactly the same again, and we're running our .NET test, and then we're saying our default task is test, right? So very similar. And I can do that by just running rake, and that will do the build first, then it should do the test, and we're done. And we can do things like running a specific task. You can do this in make as well, by the way. So I can do make build just to do the build task, and in Ruby, in rake, I can do rake build just to do the build task, if that's just what I want to do at that point in time. So that's all fine. Now, Microsoft also, when they released .NET, they released a build system called MS Build, right, which you may have heard of. MS Build looks like this. XML. Okay, so I don't know if anyone here has done any significant work in an MS Build file, but it's challenging, to say the least. The amount of time I wasted trying to figure out how to do basic string operations and things in XML was immeasurable. I wasted so much time with this, and I went through this process. So we never used Make because we were mainly using Windows workstations, but we used Rake for a while. Then we thought, well, that's a bit weird, running Rake. So we tried using MS Build. Wasted far too much time on that, and we thought, and I can actually show you this running as well. I mean, it is very similar. So again, we're just saying, we're actually defining a default target at the top. So we're saying default targets equals test, and then it's very verbose, right? So test depends on targets build, and the rest is just the same. And I should be able to, if I can remember the syntax, .NET MS Build, build.xml, the name of the file. Yes, that should work. Right. So yeah, it does work. It does work, but you're in the confines of basically coding with an XML, which is not the most pleasant experience. So at some point, I thought, well, wouldn't it be nice to do what the Ruby guys are doing, right? They're writing their build scripts in Ruby because their apps are developed in Ruby. Well, my app is developed in C#. Wouldn't it be nice to write our build scripts in C#? So we have a way of executing C#, and probably the most simple way possible is a console app, right? This is a modern .NET console app, right? One line of code, right? The program main and the class and all that stuff, that's all been removed. It's all defaulted now. It's really nice. And we should be able to run that by doing .NET run project, project targets, and it compiles, and we get a hello world, right? So it's very script-like, right? This looks very much like a script. You have got the overhead of the targets of the CS proj. It's a bit of a shame this is still required, right? Because I think the output type, I think it would be okay to default it to exe, right? And the target framework, I think we could default that to the latest target framework that's installed with the SDK. Okay, so I have, let's see what version I've got. I'm probably slightly behind. .NET version. Okay, so I've got the 8.0, the 8.0.204 SDK installed, so it could default to .NET 8.0 as a default target. So I think we could even get rid of the CS proj, right? And then we're just left with a single CS file, right? Which looks like this, right? So it's pretty much the equivalent of a script file in Ruby or Make, whatever it is. Now, we need a way of defining targets, okay? Because that's what rake gives us and that's what Make gives us. So I developed a small library called Bullseye, so I can add .NET add targets package Bullseye, and if we look at the CS proj, we should see a reference. Oh, yeah, is it being added? Ah, internet connection. That's the one thing I forgot to set up. Okay, let's try again. Come on, work for me, work for me. It's working. Excellent. Okay, and we get our Bullseye reference appearing, right? So what that gives us is a way to define targets. So we can say using static Bullseye targets. We can now define the target, and we can call that build, and let's just do the right line for now, just to keep it simple. We don't need that. and that needs to be a lambda, because that's C# syntax, and then we can go run targets and exit async, and we have to wait that because it's async. And we even get our args, right, in a modern .NET Console app. We even get args as an implicit thing, as a command line arguments. So we can pass those through. And if I then run that again, okay, yes. So I need to specify which target I want to run. Okay, and it's worked. So we've got a hello world there, right? And now, in order to default the target, I do something very similar to what we saw before in make and rake. And I can say the target, no, I don't want that yet. I can say default, depends on build. And that should now work. So now I don't have to specify the target. And it's built. Okay, good. And I don't like having to type out this every time, so I usually wrap that in a little shell script like that. Just passes through the arguments, and then that means I can just go. No, I didn't want to do that yet. I can just go build.sh to do my work. Now that's not doing anything interesting right now. So all we're doing is printing to the console. But if we do something like this, right, for running an external process, put this in here, and again, this is just regular C#, so we can define functions, we can define methods and classes and whatever we want to do. We need a reference here, we need another reference, another using there, and then I can do something like, I can actually run .NET build, okay? And similarly, I can do what we had before. I can do something like test. Copilot was actually quite useful there. And I want a no build here as well. And I'm going to make the default target test, right? So it's pretty similar to what we had before. And see if that works. Okay, we're building, and now we're testing, and you get some nice colored output and that kind of stuff, and then you get a nice summary at the end to say which targets took the longest and what percentage and that kind of thing. So it's very similar to what we saw with rake. Okay, so you've got just your .NET build, .NET test, and your .NET build, .NET test, and everything else is quite similar. We do need this to actually invoke it, right? Because it's just a regular console app. So we actually do need to invoke the actual running of the target somehow. Now, we don't want to carry this around with us everywhere, right? This run, right? Because this is a bit verbose. And actually, this is a very, very simple example. There's a lot more nuance to it if you want to get these things working reliably, especially across Linux, macOS, and Windows, right? There are certain things you have to do in Windows which are special to get certain commands to run. I don't want to go into the details because it's really ugly. But I decided to wrap this up in another library called SimpleExec. So I can install, where's my adding package? All right, I can install a package called SimpleExec. Let's watch the targets, the CS proj. And we should get SimpleExec appearing there, and that allows us to do something like this using SimpleExec dot command. Is that the one? Hang on. Yeah, using static. Okay, and now we can just rip out this, and that run command now comes from SimpleExec. And as you can see, there are a ton of other parameters here for like configuring your environment variables and other weird specific Windows stuff and cancellation tokens. And you can also go async, right? So I can also go There's also an async equivalent. And that's a lot more involved. Getting to run these things async is actually quite involved in the simple exec code. But this should now work. Oops, no, I don't want to do that. I just want to run my build script. And everything should work. Okay, good. So that gives us, and that's looking even more like our rake and make scripts now. So if I just compare them, so we've got our rake file on the right, on the left. We can get rid of these. Okay, so it gives us a very rake or make-like syntax in C#. Okay, I hope that all made sense. And so these build tools have been around. Yes, I want to show you MinVer as well. So Bullseye's been around since 2018. Simple exec has been around from 2017 onwards. MinVer, which I'll just show you now, is versioning. Okay, so we also want to version our builds, and it's especially useful for NuGet packages if you want to version NuGet packages. So at the moment, if we look at our build output, we get, what do we get? Build, let's just reset this. Let's do a git clean. Sorry, yes. Okay, so if we build it again, right, we can see that the version we get is 1.00, right? That's the default version that .NET builds. Yeah, question? Did I not show you the build SH? Okay. So the build SH, yeah, there's no problem. The build SH is very simple. Here it is. So this just, that's the build SH. So it's exactly the same command that I was running down here, that I was typing out here in full. .NET run, the project is targets, and that bit at the end just passes through any command line parameters that you specify with the build sh command. Yeah. The other stuff is just Unix options. I won't go into those now. You can look those up for error codes and things like that. Okay, and so yeah, we can see that the version coming out here is 1.00 of this package, and unless you specify the version in the CS project, it'll always be 1.00. Now, that's a bit cumbersome because it means every time you want to update your version, you have to make a commit to update that version. So what I really wanted to do was to use git tags, okay? And so I wanted to be able to tag the repository and say, this commit is version 2.00, or this commit is version 3.1.0.beta1, or something like that. And then when I build, I just get that version in my package. So I built a package called MinVer, which should do this for us. Let's just get rid of some of this stuff. Okay, and if I install that, we should get a reference to MinVer appearing. This is all rather sad because you can actually do this like this. You can say private assets, all, and you can actually get rid of all that stuff. A colleague of mine raised an issue with Microsoft to make it default to that instead, but they don't seem to be very interested, unfortunately. But the issue's out there somewhere, so do chime in on it if you want to get that changed. And now what we can do is we can git tag this with, say, 2.00. Right, and now if I build, I'm just going to do the build step. Sorry? Yes. Thank you. That should be exe. Okay, thank you. And now, fingers crossed, we should get. It's caching the build. It's caching the output objects. So I need to git clean, and then if I build again, we should get 2.0. No, that didn't work. Did I not tag it? Let's have a look. .0. Let's just do a .NET build directly. Okay, looks like the demo gods aren't with me today. Anyway, the idea is that this should just output 2.0.0, and I've done something wrong. Anyway, it doesn't matter. I use it for many projects. A lot of projects, a lot of very commonly used .NET libraries use MinVer to version. I think AutoMapper uses it. Identity Server uses it. I think Microsoft uses it internally in some of their projects as well. So it does work, I promise you. I've just done something wrong here. So, and then we've got our actual continuous integration, right? So we decided to switch all our stuff to GitHub Actions at one point. And in the GitHub Actions, you can also do a lot of very complex, intricate work. Okay, so I don't know if any of you who's seen this before, but you define your build steps, and then you can do, again, any kind of shell script you like in these kinds of things. And I've seen a lot of GitHub Actions scripts where a lot of very complex and in-depth stuff happens within this build script. The thing is that it's YAML, okay? It's not the ideal programming language, and it's difficult to recreate locally. So there is a thing called act, which kind of attempts to emulate GitHub Actions on your local workstation, but again, your mileage may vary. It's a bit limited in what it can do. It doesn't do everything that GitHub Actions can do, and some things work slightly differently. So it isn't a great way to reproduce your build. But if all your heavy lifting is done within your targets that you've defined, then in fact, all you have to do here is do build.sh. You know, okay, this is setting up your environment, so setting up .NET, doing the checkout, actually getting code onto the build runner. But the actual heavy lifting, the actual work involved in doing the build, is all behind that build.sh, right? That's what you run locally as well, right? You're running exactly the same command on your build server as you're running locally, right? So that gives you that local reproducibility. And GitHub Actions has been around since 2019. And these are not the only things that do this, right? So, for instance, there is stuff like Cake and Fake and Nuke. But for me, I chose to write Bullseye and Simple Exec and MinVer because I wanted to adhere to that Unix philosophy, that do one thing and do it well. If you look at something like Cake, for example, it's not only giving you a way to define targets, it's also like defining its own script runner, and you need a Visual Studio add-in to understand the syntax, and debugging it is not that easy. But that's all kind of done for us, right, by the modern .NET Console app. It's very, very simple. It looks like a script, and all the debugging and all the ID integration is there for you already. So Bullseye only concentrates on that one thing, giving you that way to define and run build targets. Similarly, Simple Exec does that one thing. It just runs external commands. MinVer only does the versioning. So, I guess I've come towards the end. I've shown you my build chain, the philosophy behind it, which is based on the philosophy which I believe sort of underpins modern computing. You know, I don't know if Bullseye, Simple Exec, and MinVer are going to be around in 50 years, but you know, it will be nice. So we'll see. Who knows? Okay, so I guess we're quite ahead of time. So, are there any questions before I wrap up? Yeah. Ah, okay, all right. So your question is, I'm recommending to run a single sort of build sh at the end of the as a step in the GitHub Actions YAML, and what do I recommend for building matrix builds, like running on different OSs and different versions of SDKs and things like that. So I still do that, okay, but you see that part is not the bit that you necessarily recreate locally, because you wouldn't, on your single machine, you wouldn't necessarily want to recreate building on Linux, Mac OS, and Windows, because that's going to be difficult, especially Mac OS, right? So that part is like the infrastructure level stuff that I would do in a GitHub in a GitHub Actions matrix. So I can actually show you, because I do that for my projects. So I should be able to show you that actually. Let's have a look. Ah, sorry, yes, thank you. So let's show you. Let's go to simple exec, because maybe the simplest. So here is the CI workflow that I use for simple exec, and here you can see that I am using a matrix of Mac OS, Ubuntu, and Windows, right? So in exactly the same way. And here, because, so where's the build script itself? Oh yeah, so again, I'm just using the build, I'm just calling a build here. I do pass the logger as GitHub Actions here, but again, that doesn't apply locally because it's not GitHub Actions, right? So, but essentially, the /build is a build script, just doesn't have that sh extension. But all I'm doing here is running exactly the same thing as I run locally. But that infra level stuff is lifted out into the GitHub Actions YML, because I think that's where it belongs. Yeah. Oh, I can hear you. I'll repeat it. Yeah, yeah. Right. Right. So the question is, am I also using containers to do things and running apt-get and things in containers to do stuff? Well, yes. So we do that in some instances. But again, you can decide where to do that. You could do all of that inside your build targets, right? That's a place you can do that, because you can run any command using any external commands. You can run a Docker command, right? So you could do that there, and I'd probably look to do it there first, because then I'm still doing that same build.sh locally and on the external machine, right? So there's no reason you couldn't do that, right? Because those are just arbitrary external commands. But that's not a silver bullet. In some cases, it may be better to do something above that. It really depends on the specific context. But there's no reason you couldn't do that within the build targets as well. Yeah. Anyone else? Any more questions before I wrap up? Yeah. Which one do you want to see? Sorry. Ah, the release YAML. Sure. Yeah. Okay. That's so this works on tags, right? Because I use MinVer to version simple exec. So whenever I push a tag to GitHub, I want this build to kick in. And this one, the CI and everything's already run on all the different matrices and different OSs and things. So I just build it on one OS. I chose Ubuntu, and then I just push it to, I think it's, I was using MyGet, now I'm using Feeds.io, I think, and I'm just pushing it there. And then I manually move it to NuGet when I'm ready. Okay, all right, so I'll let you get out ahead of the lunch queue. Thank you very much for joining me, and I hope you enjoy the rest of the conference. Thank you.